Hey everyone, welcome back! In today's video, we're taking you on a journey all the way back to the Hadean Eon. It's the oldest chapter in Earth's entire geological history. Earth, Mars, and Venus. These three planets started off surprisingly similar when they were just beginning to form. And yet, somehow, life took root only on Earth. Why didn't it happen on Mars or Venus? That's the mystery we're about to explore together. You're watching our channel, and we're glad to have you here. If this topic sparks your curiosity, then join us as we dive into a cosmic investigation to figure out who really stopped the Martians and the Venusians before they even got started. Alright, let's jump in. Earth-like planets. What do they look like today? About 100 years ago, people still seriously believed that life might exist on Mars or Venus. And not just microbes, but actual intelligent life. Sci-fi writers eagerly sent their heroes off to explore Mars and Venus. And even scientists took seriously the idea that the massive canals seen by Schiaparelli on Mars were incredible feats of Martian engineering. But once the space age began and real data started coming in, those dreams were completely shattered. We learned that Mars has barely any atmosphere at all and is nothing more than a desolate, lifeless wasteland. Venus, on the other hand, turned out to be a true vision of hell through the eyes of scientists. Its atmosphere is incredibly thick, so much so that the air near the surface behaves almost like a liquid, and the temperatures are so extreme that even lead would melt into a bubbling soup. But things weren't always that way. Today, we have solid, undeniable proof that Mars once had oceans, lakes, rivers, and even entire seas. And there's a good chance Venus did too. Where there's water, there's the potential for life. So then, what happened? Where did all that water go? Young Earth, a terrifying world. Alright, to start unraveling this murky mystery, it's time we head back into the past. Let's make sure we're fully prepared for the trip. We're heading to an era where Earth's atmosphere was anything but breathable. So hold on tight to your spacesuit. You're definitely going to need it. The period right after Earth was born is known as the Hadean Eon. This era came to a close about 4 billion years ago, and after that, the Archean Eon began. Back then, the Earth was blanketed in a thick, choking atmosphere made mostly of carbon dioxide, methane, ammonia, and hydrogen sulfide. There probably weren't any continents at all. The earliest landmass we've been able to confirm so far is called the continent, which formed about 3 billion years ago and was smaller than today's Australia. So, at that time, Earth was just an endless rolling ocean, stretching as far as the eye could see. And that's where life first began. Earth was constantly bombarded by a relentless shower of meteors. Then, one day, it collided with another planet named Theia. Theia was about the size of Mars and originally shared Earth's orbit around the Sun, trailing or leading by about 60 degrees. But gravitational disturbances eventually knocked Theia out of place and sent it hurtling straight toward Earth. The debris from that violent impact is what eventually formed our Moon. Back in those days, the Moon was much closer to Earth than it is today. If you could have sailed across those ancient oceans and looked up through the thick clouds, you would have seen a massive glowing blotch in the sky, covering nearly a quarter of the entire heavens. The Moon's gravity sped up Earth's rotation, which stirred up violent storms in the skies and unleashed colossal waves in the seas. In short, Earth at that time was nothing less than a living hell. If we stay here too long, both our lives and the time machine could be in serious danger. We should probably head to Venus while we still can. Venus and Mars. If only they had known what was coming. Ironically, back then, Venus actually seemed like a more comfortable place to live than Earth. One of the biggest reasons was that the Sun was still young and much dimmer than it is today. Right now, Earth sits almost perfectly in the middle of the Sun's habitable zone, while Venus and Mars are positioned closer to the edges. But around 4 billion years ago, it was Venus that stood right in the heart of that life-friendly zone. It's hard to say exactly what the temperatures were like on Venus, Earth, and Mars at the time, since it all depended on how thick and what kind of atmosphere each planet had. But of all three, Venus likely had the best conditions for life to begin. Today, Venus has a crust that's surprisingly young, estimated to be less than 1 billion years old. By that time, though, all of its water had already vanished. So unlike Mars, Venus hasn't given us any direct evidence of rivers, seas, or oceans. No riverbeds or sedimentary rocks have ever been found. That said, there's no proof they didn't exist either. Venus didn't have a moon orbiting around it like Earth does. Some experts believe that Mercury might have once orbited Venus, but even if that were true, it likely broke away early on and became an independent planet. That means Venus had no tides and no storms, and it probably offered a much calmer and more stable environment. You could almost call it a paradise. Interestingly, there's a bold theory suggesting that life actually began on Venus and was later delivered to Earth. According to this idea, a massive geological upheaval on Venus sent pieces of its surface flying into space, where they eventually landed on Earth as meteorites. One day, we might even find solid evidence to support that theory. So then, what about Mars? In its earliest stages, Mars was simply too cold to support liquid water on the surface. But over time, much of its ice eventually melted away. We don't know for sure whether that happened because its thick atmosphere created a runaway greenhouse effect or because the sun had become hot enough to do the job. What we do know is that Mars, just like Earth and Venus, was once covered in vast oceans. That era in Mars's history is known as the Noachian period. The Three Sisters: Parting Ways. During the Hadean Eon, Venus, Earth, and Mars were strikingly similar in many ways. The only real difference was that Mars was a little colder than Earth, and Venus was just a little warmer. But from that point on, each one followed a completely different path. Earth slowly began to take on the shape we recognize today. As the sun grew brighter and hotter, Earth's surface gradually warmed up. Meanwhile, the moon helped slow Earth's cooling from the inside. Some scientists believe the moon may have played a key role in sustaining Earth's planetary dynamo. That dynamo is the movement of liquid in the Earth's outer core, which creates our magnetic field. This strong magnetic shield protected Earth from the harsh effects of solar wind. Then, in those ancient oceans, the first life began to emerge. It's possible that life may have arrived from somewhere else, but that's not the focus of this video. Over time, life evolved and developed the ability to perform photosynthesis. That change led to a gradual increase in the amount of oxygen in the atmosphere. Eventually, Earth's entire atmosphere underwent a dramatic oxidation, transforming into the kind we breathe today. Most anaerobic organisms died out, while those that adapted to the new conditions survived and became the ancestors of all modern life. We already covered this great oxidation event in another video, so we won't go too deep into it here. Meanwhile, Venus descended into the fiery nightmare we see today. As the sun grew even more intense, the oceans that may once have covered Venus began to evaporate. That triggered a runaway greenhouse effect, and the surface temperature began to skyrocket. On top of that, Venus lost nearly all of its magnetic field. We still don't know exactly why that happened. Maybe the extreme heat stopped the mantle's convection currents altogether, or maybe some catastrophic event slowed Venus's rotation to a crawl. Whatever the reason, Venus became completely exposed to the full force of the solar wind. And it was likely that solar wind that broke apart the water vapor in Venus's atmosphere and stripped it away. Mars, for its part, ran into bad luck of its own. About 3.7 billion years ago, the Noachian period ended and the Hesperian period began. Mars may have still had bodies of water during that time. The Borealis Basin might have held a large sea, while the Austral highlands were likely covered in glaciers, rivers, and countless lakes. But sadly, that incredible landscape was already on the path to destruction. Mars's atmosphere kept getting thinner and thinner. We still don't fully understand why Mars lost its atmosphere. For a long time, scientists assumed it was because Mars is so small that its gravity was too weak to hold onto it, but now we know that's not the whole story, since there are even smaller worlds like Saturn's moon Titan that still have thick atmospheres. Today, we believe the real answer is much more complex. More precisely, it likely came down to a combination of different factors. One of the biggest culprits was probably Mars's weak magnetic field. which left the planet wide open to the effects of solar winds. Unlike Earth, Mars didn't have a large moon stirring its core or generating electrical currents in its outer layers. Sure, maybe its gravity was just strong enough to hold on to some lightweight molecules, but many scientists still argue that Mars was simply too small, with gravity too weak to protect its atmosphere. In any case, by around 2 billion years ago, at the tail end of the Hesperian period and the beginning of the Amazonian era, Mars had lost nearly all of its atmosphere. It had only about 1/200th of the pressure of Earth, and the surface pressure dropped below 1% of what we have here. Under those conditions, Mars cooled rapidly, and its oceans gradually evaporated away. That said, some water deep beneath the surface remained trapped in frozen layers of permafrost. Sometimes, Mars quakes cracked that permafrost and water burst out onto the surface. For a short time, those waters flowed freely across the land, but they eventually turned to vapor, which was then broken apart by solar wind and lost from the atmosphere forever. By about 1 billion years ago, sometime in the middle or later stages of the Amazonian period, Mars had become the barren, geologically quiet desert we know today, with no signs of life left on its surface.